Alright guys, this is section 7.3, using functions involving e. Now, we're going to simplify expressions involving e and graph functions with e. And the first question is, what is natural base e? It's going to be an equation that looks something like y equals e to the x. This e is an irrational number. Now, irrational means something, number, looks something like pi, or square root 2, or square root 3, and so on. It is a number that, or a letter that has a numerical value. Now, this value is approximately 2.7182818828, and so on. Now, it's just like pi. Pi is 3.14, and it keeps going forever and ever. This is your value for e. Now, if you're using the little yellow calculators or a calculator that looks just like our little yellow calculators that we have in class, e is going to be located where you hit the second function, and then you're going to hit the key that has ln on it. So it's going to be ln, and then it's going to have a little e to the x on top of it. Now, when we're using this key, what you're going to do is x, you're going to type in some sort of value, and your calculator is going to pop up with an e and then a little symbol like this, and you're going to write in like squared or something along these lines, and it will punch out some sort of decimal for you in the calculator. Now, the first thing we're going to do is we are going to simplify problems with e in them. So the first one is e to the 7th times e to the 4th. Now, e is the same base, so that means I'm going to add my exponent. So I'm going to have e to the 7 plus 4, which is just equal to e to the 11th power. And you can just leave it like this since e is a value. It's just like pi. If I have pi squared, I'm going to just leave it as pi squared. Now the next one, same type concept. Everything here is being multiplied. So I can rearrange this and make it 2 times 6 times e to the negative 3 times e to the 5th. Now, 2 times 6 is 12. And since I'm multiplying two numbers with the same base, I can add my powers. So I'm going to end up with e to the negative 3 plus 5. So I'm going to have 12e squared. And that's my answer. This is where those properties that we learned, or the properties of exponents that we learned, come in handy, because we're going to keep using them throughout the whole semester. Now, the next one thing I can do is I can reduce 28 over 6, and I can divide both of these numbers by 2. So I can reduce this to 14e to the 8th power divided by 3e to the 5th power. Now I have same bases for my powers, so I'm going to subtract my powers. So this is the same as 14 over 3 times e to the 8 minus 5. 8 minus 5 is 3, so I'm going to have 14e cubed over 3. And then I can just leave it like this because there's nothing else I can do to it to simplify. And the last one. Now remember, when I have a power to power, I can almost distribute this. 3, it doesn't count as distribution, but since this is multiplication, it has to go to each piece. So I really have 10 cubed times e to the negative 4x cubed. Now I have power to power, so I'm going to multiply my powers. So I have 10 cubed times e to the negative 12x. Now 10 cubed is 1,000, so I have 1,000 e to the negative 12x. Now my negative is going to move this portion, or the second portion of my equation, down to the bottom. So I'm going to end up with 1,000 divided by e to the 12x. And then you can just leave it like this. Okay, next thing, natural base exponential functions. We are going to have functions that look like this. We're going to have y equals ae r to the x, and y equals ae to the negative r to the x. Now, if I have a positive r, so if my r is positive, then we are going to have a growth chart. So this is going to be an exponential growth. So positive r is exponential growth. Or we're going to have negative r, and if r is negative, I guess I don't need my negative sign there. If r is negative, then I'm going to have an exponential decay. Now, we've already talked about exponential growth and exponential decay. We should have the general idea of how the shape works. Now, when we are doing these, we're going to have the same steps as before. Nothing is changing. The first step is going to be plot the y-intercept. And remember, our y-intercept is equal to a. And then we're going to plot another point. Sounds simple enough. It's going to be the exact same as it was before. So now for our first example, we are going to look at this equation, and we're going to first look at our original, which is y equals ae r to the rx. Now, r can be negative or positive. In this case, our r is 0.05. So, since it is 0.05, that means my r is positive. So that means I'm going to have a growth. It is going to start somewhere down here and go up here, or it is going to start here and go this way. Now, the first thing is find my y-intercept. So my y-intercept is equal to a. A is 2 because a becomes before my e. So my a value is just 2. So my y-intercept is going to be 0, 2. So I'm going to be at 0, and I'm going to go up 2 to here. Now I'm going to pick another number. I'm just going to pick x is equal to 1. So then I have y equals 2e to the 0.5 times 1. And I'm just going to punch that in my calculator and get approximately 3.3. So my next point is going to be 3.3. So I'm going to go over 1 and up 3 and a third-ish. So right about there. And then I'm just going to draw my graph. So I'm going to go up this direction. And my asymptote is here since I don't have a k. And so I'm just going to come down. And I shouldn't have passed that line. My asymptote is here, and my line should go right there. Just like that. So, not much different. You're still going to plot your y-intercept and pick another point and graph it just like normal. Just now you're going to use your calculator and punch this in so that you can get some sort of decimal. Now the next one. We have our y equals ae r to the t, and then we have a plus 1 at the end. And remember, our plus 1 is just going to be our k value. So, I have, first things first, I'm going to decide if it is a growth or a decay. And now I have negative x. So I could rewrite this as 1/2 e to the negative 1 times x plus 1. Now I have my r times my t. And my negative 1 is going to make me think that my r is negative. So I have r is negative 1. And if it's negative, then it is a decay. So that means my graph is going to look something like this. Now, first thing I do is find my y-intercept. So I have my y-intercept is equal to A, which is equal to 1/2. So my point is 0, 1/2. So I have 0, 1/2. So right there-ish. And then I'm going to pick another point, and I'm going to pick x is equal to negative 1/2 so that I end up with a positive exponent. So I have x is equal to negative 1. So now I have y is equal to 1/2 e to the negative times negative 1. So now I have 1/2 to the e to the first power, which is approximately 1.4. So now my next point is negative 1, 1.4. So I'm going to go back 1 and then up 1.4 here. Now I have a plus 1. So before my plus 1, I'm going to draw in my graph, and I'm just going to dot it so that we know that it's not our final graph. And I have my asymptote, which is at x is equal to, or y is equal to 0. Now, since I have a plus 1 at the end, I'm going to raise my asymptote up 1. I'm also going to raise my red point up 1 and my blue point up 1. So now my new graph is going to look like this. And it's going to come down. Whoa. Sorry about that. It's going to go up here and come down this way and hug my asymptote. It's a really bad picture, but you understand the point. I'm going to just scooch all of my points up, so then I have my graph that goes this way and comes down and hugs my asymptote. That was better. All right, now I want you to do the next one, but I'm going to get you started. So the first thing you need to know is that when you see this, I'm going to have to distribute my 0.25. So I'm going to end up with y equals 1.5e to the 0.25x minus 0.25 minus 2. Now, I want you to look at this piece. This is going to be my h, so I'm going to shift everything to the right, 0.25. And then this is going to be my downward shift of 2, since it's minus 2. And then I have my y equals ae to the rt function right here. So you're going to do the same thing as before, and then you're just going to shift it right and then shift it down. Okay, last example, your favorite, word problems. So continuously compounded interest, we're going to use this formula a equals p to the ERT. A lot of people say a pert to help you remember. A is going to be the amount in the account, and P is going to be the principal, which is the starting amount, which is kind of like our initial. Just like in our other equation, it is going to be our initial, if I can spell. And then R is our annual interest rate expressed as a decimal, and T is years. So we're just going to plug in what we know. So we have, you deposited $2,500, $2,500 in an account that pays 5% annual interest compounded continuously. Find the balance after each amount of time. So our first one, we have our P, which is our initial, which is $2,500. And then we have our rate, which is 5%, or we could write it as 0.05. Now, our A is 2 years, so this is equal to our T. So now I'm just going to plug it into our equation, which is A equals P e to the RT. So A equals P e to the RT. Now I have P, which is 2,500. So I have 2,500 e to my rate, which is 0.05 times 2. Now, I'm just going to type this directly into my calculator. So A is going to equal $2,762.93. All you're going to do is take your calculator and type this in directly. You are not going to change anything. Just type it in and it will pop out this number for you. Now, I want you to do 5 years and 7.5 years on your own and see if you can figure out the answers. I will see you tomorrow.